So, from a designer's aspect, I'm going to come back to our kind of mixed-use building, and I think as a designer, we're very good at selling a dream to our clients, and particularly a dream about how smart and how integrated our building is going to be once it's operational. They'll have a fully integrated BIM that will be passed down to their FM team, that they'll know everything about every system within their building, and they'll be able to use it for future maintenance as well as future fit-outs of the building. The building will be fully smart and will interact with occupants. We'll have a all singing, all dancing building management system that will alert the FM team about any kind of maintenance issues and optimise comfort. We've got a fully functioning energy monitoring system with full submeters that tell us exactly how much energy use is used in every space, and allows us to run the building as efficiently as possible. We've got smart lighting that is reacting to daylight levels and is optimizing all the light levels within every single space within the building. Our renewable energy systems and our low carbon systems are busy creating low cost energy. Our smart assets are making use of things like plunge pricing on the grid, and we're getting a great rate of return on those systems. Our occupants are delighted because they're using their iPhones or they're using intuitive controls to optimize comfort for their particular needs. However, kind of all too often, I think we've got to be really careful as designers that in this striving for intelligent buildings, that we don't end up creating a building that is actually inherently quite thick. So this is the sometimes grim reality of things. The sun has gone, the clouds have come in, the tenants are ripping their hair out, and the facilities managers are looking confused in the plant room. They're using a lot more energy than they're expecting to. Within the industry, if you look at the Innovate UK work that was done about 4 or 5 years ago of 100 post-occupancy evaluations of new buildings, there is a performance gap of about 400%, so 4 times. So the energy that we're expecting at design stage, in reality, it ends up being 4 times that size on average. That is leading to higher energy bills, and the tenants aren't too happy about that. Our building management system, nobody's really looked at it since it was commissioned. The facilities manager's a little bit confused by it, and it's perhaps not what it was expected to be when it was installed. The FM team, they've got a really overly complex building, and they're really struggling to kind of maintain it properly. Our energy metering and logging system, nobody's actually looked at it yet, and when somebody does look at it, they realise that a lot of the meters haven't been calibrated properly, and they're reading 0. Nobody's really using it for efficiency and optimisation. The CHP engine that we installed for planning conditions has been decommissioned and turned off because it wasn't generating that much electricity, and it was costing more to run than people had expected. We've taken a lot of the control away from our occupants by having a BMS that's controlling all the temperatures, and this has kind of disempowered them. They getting frustrated by the fact that they can't interact with the space. The handover was a little bit rushed because kind of construction took a little bit of time, and it got squeezed into a really quick period. Nobody really recorded any information, and people haven't opened up the O&M manual since it was delivered. Some of the tech that we've put in, it's been discontinued by a manufacturer, and we can't get any support left for it. Probably shouldn't be saying this in this kind of arena, but perhaps there's a bit of a smart building agenda going on, and there's just lots of suppliers looking to sell as much tech as possible and brand it as being smart. So we've got to be really careful about, as a designer, is not creating that reality, and we also got to look at the opportunities of what's to come in the future. So this is our future building. People going around on hoverboards. We've got my morning coffee is delivered by drone, so our buildings might need to integrate potentially with drone technology. We've got our driverless cars down in the basement, and we're using the batteries from those cars as part of the energy source within the building itself. As Rakesh said, there's going to be a lot more reliance on mobile data and the 5G network, and perhaps our buildings might need to change a little bit to better integrate into that. Lots more use of wireless technology, which we're already doing, but I think we're only going to see more of that, and more use of smartphone. Using voice controls, much like Rakesh said, the FMT might be using voice controls to manage energy and control within the building. Augmented reality perhaps within the workspace. So we don't want to create the clouds and the grim reality, and we've also got to look to the future. And as designers, what do we need to do really to get to grips with this? I think going back to the basics, we've really got to define our brief within relation to intelligence of buildings as best we can. And that needs real, open, honest conversation with clients. Are they fully aware of the cost implications of some of the systems we're looking to integrate into the buildings? Do they have a good understanding of the way that they want to maintain and manage the building? Because that has a lot of influence on perhaps the systems that we choose to design for that building. We've got to really be aware of what's going on with the occupants. What do the occupants want out of their building? Typically what they expect is comfort. And that should be a given, that they have a comfortable environment with good air quality and a stable temperature. But actually when you speak to occupants, really things that are important to them are elements of the building infrastructure. Mostly the toilets actually, when you do post-occupancy evaluations, all the feedback you get back is really on the restroom facilities. In terms of intelligence, we've also got to think about the site constraints that we've got. Have we got a fibre optic network in the area that we can connect to and improve our upload and download speeds? Perhaps we can link together with a surrounding building that has some of that tech or has cloud server storage available. We've also got to think about the environmental aspects of our site and the implications that might have on a building's intelligence. Is air quality really, really poor in the area, or are there a lot of noise issues in the area? That might lead us to a bit more of a high-tech solution with mechanical ventilation systems that might well warrant a fully integrated building management system. And are we being pushed towards an element of complexity and intelligence within our buildings through different planning targets that we have, particularly around CO2? Should we perhaps be pushing back on some of those them items in order to create just better buildings in general? And really the question that we need to pose to ourselves, is there a necessity for complexity? Somebody who does a lot of post-occupancy evaluation, a good friend of mine is Rod Bunn at Bizria, and a phrase that he always uses is that complexity is the enemy of good performance. And actually, if we can keep buildings as simple as possible, then we might have a better chance of making them perform better from an environmental perspective. Perhaps a good example of this, a project that we've done a POE study on is this secondary school in High Wycombe that we worked on. On the left is the building before construction, which was naturally ventilated, heated through gas boilers, a very, very basic building. On post-construction, they had a very modernist building built during building schools for the future with very, very high environmental aspirations. And that building hasn't got any openable windows. It's got a fully sealed building with a mechanical ventilation system that reacts to CO2 levels. It's got a ground source heat pump, and it's also got a biomass boiler to further reduce CO2 emissions. And unfortunately, in the first few years of this building's operation, energy bills were really, really sky high, and the facilities management were really struggling to deal with it. The caretaker for the existing building really was struggling to deal with the BMS that they were delivered. So perhaps as designers, we should be been a little bit more aware of those issues to provide a little bit more simplicity. It's really about horses for courses. Intelligence is probably, and smart tech is probably very valid for buildings such as the Bloomberg building that won the Stirling Prize earlier last year. But a building that I really, really like is Mildmay Community Centre on the left, which is a passive house project with a community centre that have just got really basic intuitive controls, and it's really running really well and has very, very low energy use. We've also got to make sure as designers that we learn from others. We do a lot of work with Costa Coffee, and they have a product which they call the EcoPod, and we're now on the 4th iteration of the EcoPod, and every time we're going through post-occupancy evaluation, monitoring energy use and learning from that building, and then putting it into the next Costa EcoPod to constantly make it a better product. We've got to make best use of the industry standards that are out there and the case studies that are out there. The IET have got a code of practice for connected systems and integration in building, which has got lots of really useful data in. And similarly, the Building Data Exchange has got plenty of case studies of new buildings and the performance of those buildings, areas that have gone well and areas that have gone not so well. And when we get onto the more kind of detailed design aspects and looking at specifying different network systems and AV systems within a building, we've got to make sure that there's an element of consistency within our network protocol, and that is transferred the whole way through the design stages, planning stages, installation, and then through to the operation of that building. We've got to have a real holistic view of everything we do. There's got to be a lot of design on user interfaces and how tenants and occupants interact with that. We've also got to be fully aware of how that pyramid system of how many links that has to other tech and other systems within the building if we're going to have full awareness of how we design. Potentially we've got to think about designing for failure as well. What happens if the 5G network goes down or the internet goes down? Do we now have a building that can't operate? We need to have a think about how we can have some fail-safe options there. And I think really, in order to, as designers, for us to really make our intelligent buildings work, one of the key things that we need to do is to integrate different kind of frameworks and protocols such as soft landings, which have got a real, they really focus on commissioning, handover, during the early stages as possible. They really focus on training, making sure that all of our building information is corrected in place, that goes on into seasonal commissioning, and also obviously into POE activities. And it's really crucial that we kind of have that engagement of the FM team throughout that entire process. That is the last of my slides. Thank you very much.